I was like, "Do you want to do a PhD?" He's like, "Yeah, why not?" So I was part. Yeah, easy, right? So yeah, we did that. We did that essentially, and that's how I got into quantum computing.
So here at the QuantumTech conference, I met Kostas. Please tell us a little bit about what you're doing, because you are also a speaker here, right? I'm super excited about what you're going to talk about this afternoon.
Yes, so I am an application engineer, a quantum application engineer within the National Quantum Computing Centre. It's part of the UK's National Quantum Technologies Programme. So I work with developing applications or thinking about algorithms or trying to develop solutions to problems using quantum computing and understand if quantum computing can do anything useful, when can it do that useful thing, what are the applications, how do we think about problems, so all of those things combined. I'm a technical guy essentially. I do a lot of high level stuff as well, but my main role is technical.
Yeah, technical is of course super important, and because I was super excited to talk to you was exactly the question of real life applications of quantum technologies, because today I think there are no real life applications yet, but people are already preparing and investing a lot of money in there. What would you say are the most important fields or use cases where we can expect quantum technologies in the next years?
Yes, that is an interesting question and quite a difficult one to answer. So the what applications and when is the question I usually think about. On the what application side, so I mean, I'd like to think about use cases in terms of sectors. So we see, for example, in the energy sector, there's use cases that have to do with nuclear reactors, radiation transfer in nuclear reactors, optimization of electricity grids, things like that. So in finance, there's also a lot of interesting applications. There's a lot of impact that quantum computing has the potential to cause in finance, using modeling of real life markets or scenarios, evolution of markets, portfolio optimization, fraud detection. So especially cryptography as well. So quantum computing has a lot of impact in cryptography, as well as a lot of opportunities in terms of providing solutions on post-quantum cryptography algorithms. So yeah, there's a wide range of applications. Now, the question I always get is, okay, when are we going to see something coming out of quantum computing? Because yeah, currently we see all the theoretical evidence, we see all these algorithms that can solve us problems, but we cannot see that in practice. And to my annoyance, the answer to the when question is, well, I'm not really sure. So there's so much research that you need to do, so many enablers and underpinning tools and technologies that need to reach a specific state of maturity to enable us to run applications throughout the entirety of the stack. So there are different layers that these technologies come in. So you need to do a lot of work in order to be able to run something reliably. But we also see progress, right? We see hardware getting bigger, hardware developing, evolving, different platforms coming in, software solution, different toolkits arriving. So we might start to see some things that we haven't seen before. So hopefully, we're all hopeful, and it's all talking about potential. But yeah, again, we're optimistic, so we're trying to be optimistic.
What brought you into quantum technologies? I think it's quite a magical field, and it's so hard to explain to someone how it actually works. But how did you find your love for quantum technologies?
So I was always into quantum physics, first of all. I did an engineering degree, so I'm an electrical engineer, I'm a bachelor's degree. Then I did a master's in computing science, data, so nothing quantum, but I was reading quantum on the side. So in university, Newcastle University in the UK, I found my supervisor, and I read on his website that he's interested in quantum computing. And I was like, do you want to do a PhD? He's like, yeah, why not? So I was part, yeah, easy, right? So yeah, we did that essentially. And that's how I got into quantum computing. And then I got into the industry. So yeah, enjoying it so far.
Can you explain to me how a superposition is working? What is that?
Yes, so it is not as difficult as you may think. Is the idea, I mean in technical terms, is the idea that a qubit, the fundamental unit of quantum information, can be in a superposition of two possible states, so the ground state and the excited state. Essentially, you can think of it as being in two states at the same time. You have the classical bit, which can be the 0 or 1. A qubit has a probability to be in state 0 and a probability to be in state 1. That happens in a closed environment. So only if you put it in a black box, let's say, think about Schrodinger's cat. You're sick of hearing about Schrodinger's cat, probably.
I love it.
You do? Okay.
That's the one thing that I understand about quantum physics.
Okay, fair enough. So I guess superposition is the idea that a quantum state can be in multiple states at the same time. And you can use that essentially to store more information. You can use it to run multiple, thinking about it as parallel computing essentially, like you're developing things in the parallel. very, very abstractly.
But we are always trying to teach people something, and so now everyone learned about the superposition.
Well,
what do you expect quantum technologies to have an impact on the work market?
Well, as far as I can tell, we're already seeing impacts. So there is a skill shortage, or we like to say there is a skill shortage in the UK as well as abroad, on people that have the skills to do R&D, so research and development in quantum computing. So we're already seeing impact of that. So there is already some sense of wanting to develop the workforce, develop the skills, and the NQCC, that's where I work, has programs for developing skills, because quantum computing is so fundamentally different to classical computing.
Yeah.
Like you need to think in a different way, you need to develop workflows in a different way, develop solutions in a different way. So you need people to think in a different way. So that is an interesting aspect.
Yeah. All right. Thank you so much for your insights.
No worries.
And enjoy the rest of the conference.
Fantastic. Thank you very much.